Some time ago, I switched from CMRI to MQTT as a way of communicating all of the accessory stuff, all of the signals and the turnouts, motors, all that stuff to and from CMRI. And since I did it, I've got kind of at the time I did it, I had 3 CMRI nodes, and the other 2 didn't give me the slightest issue. They just worked as soon as I put the code on and turned them on. This one took me 3 months to get working. At the time when I switched, this Arduino had a lot more cables connected to it than it has now, and it was doing everything, all of the accessory stuff it was doing. It was the only little computer type thing down here, and when I couldn't get it working, I realized what the kind of the quickest, what seemed to me the quickest route to get it working was to take everything off it, start taking everything it's doing off it, and see when it started working, when which bit was removed, it would start working. But in order to start taking stuff off it, I really wanted an alternative. I wanted to be able to put the stuff I was taking off it somewhere else. I didn't really have any Arduinos, and I was starting to not trust Arduinos. So I decided it was a good opportunity to start testing out all of the other devices that were kind of, I was discovering, I guess, and that I was learning about. There's one down here somewhere. There's an ESP32 down there, and this is an Intel Galileo. And what that journey, what that experience kind of ended up being was a kind of a journey into kind of alternatives and the differences between the devices and which devices are useful where. And actually what I ended up with was not deserting any of them and using all of them. So the process of switching or moving from an Arduino that was absolutely broken and didn't work to a corner that now does work with a much reduced workload on the Arduino ended up being quite interesting in that it was a comparison of different devices like the Galileo and the ESP32, and maybe from my point of view what their strengths and weaknesses were. So this, unsurprisingly, was the centre of all the problems, and that's unsurprising because at the time it did everything in this corner. It was connected to a PCA9685 board and was controlling 8 servos. From that board it was also controlling 8 relays for electrofrog polarity. It had shift-in registers coming for a load of infrared sensors that are kind of dotted off down there. It had shift-out registers going out for the signals that are there, and a few that are further down the other way as well. And it had sensors directly connected to it for there are maybe 3 or 4 different current detectors dotted around here as well, and it was controlling them as well. So all very convenient when it works, but when it stopped working, that meant everything in this corner died. So I started off by taking all of the servos off it and plugging them into this, an ESP32. And that created a few problems that I wasn't expecting, which I will go into later. Having moved all of the servos onto the ESP32 board, and I moved all of the micro switch sensors at the same time, the feedback sensors, I was left with working servos, but the way I had it, weirdly, the relays that do the electrofrog polarity were plugged into the PCA9685 board, because that was just the way I did it. So with the PCA9685 board being disconnected, I needed to find another way of managing the relays, and in the end I went for managing them through shift registers, which were connected to this. This is an Intel Galileo. A friend recommended me buying them. You can buy boxfuls of them now, and it's kind of a very basic Linux box that runs, I can best describe it as an Arduino emulator. It's got the pin headers over here for equivalent of an Arduino Uno, and it runs Linux from a little memory card down here, and you can then upload sketches to it the same way as you would an Arduino. You can plug devices to it there, and it will run Arduino sketches and behave like an Arduino. So I brought this on, and I'll talk more about that later too. Let's start with the ESP32 then. As I said earlier, I bunched all of my servos onto that, and also the micro switches that control feedback. It led to some kind of interesting thought processes for me, I think. A few big decisions, especially around micro switches, and a few lessons learned as well about using servos for a model railway layout with an ESP32. So I did kind of record all of the issues that I came across, the problems as I came across them, and then eventually what I did to resolve them. So I'll try and add those next. I've written a little Windows application that speeds up calibration quite a lot of the servos. Previously, I had a calibration sketch that I'd written, and I'd upload that and I'd play with all the settings, and I'd get the servos to a point where I was happy with them. Then I'd copy those settings into the sketch for the actual MQTT node, and then I would upload that MQTT node, and invariably there'd be some changes I need to make, and I'd have to change the sketches again, and that got a bit tiresome. So what I kind of realized with MQTT is that it's not a closed box like CMRI was. The sketch that's live, the node sketch that's on the device, whether it's an ESP or an Arduino or whatever, will listen for messages, and if I put a little bit of code in the sketch to respond to those messages, it doesn't care where those messages came from. They don't have to have come from JMRI. The messages can go to the MQTT server from anywhere, and then those messages, if the node is subscribed to them, it'll receive them. So what I kind of did was twofold to make it possible to do live calibration of servos while the layout's running. The first thing I did was wrote this simple Windows program, so that I kind of got an interface to do this from, and it's got simple settings. The server, the MQTT server I want to send messages to, the topic that I want to send on, so I've got a special kind of debug topic, so I'm not interfering with the actual turnout ones, and then a closed value and a thrown value, and a couple of other options like degrees, which I'm not currently using anyway, and then the send closed and send thrown simply sends a message closed or thrown with those PWM values into the MQTT server. The MQTT server then sends those values, whichever value gets entered from here, into the node, and the node acts on it with some additional code that I wrote in the sketch. And it just means that from here it should work. I think if I start clicking this stuff now, if I go click close, send closed, there was a slow move somewhere there on what is ID 5003. And there it is moving again. And that's, even while JMRI is running, I could, the same turnout, I could click from here. And they're all responding as well. So it's kind of all the same thing. I think it's made the calibration a little bit more accurate as well, because it's the same code engine that's acting on these values. So these are slow, whereas my calibration sketch moved all the servos instantly. It's now I'm able to calibrate it with the slow move as well, which really helps. A source of immense frustration throughout the calibration process and learning these new things with ESP32s is I would come and I'd set the calibration up on say this turnout, and go through lots of values, test values. I got till I was really happy that thrown was out here and obviously closed, and the blades would be down here. And I'd test it, and I'd make sure it was fine. I'd upload the values to the ESP and it would work fine. Then the next day I'd come along and at maybe 2 or 3 servos suddenly seemed to have completely different movement, in that something that worked perfectly yesterday with the same values today would maybe you'd hear it kind of as the blades went to say thrown, you'd hear the motor really struggle because it was trying to go further than it physically could, And when you switched it to closed, it would hardly budge this way at all, and you wouldn't get the blades closed, even though yesterday it was perfectly calibrated. So I'd say, right, okay, I must have made a mistake, and I'd calibrate it again and get it perfectly, and it would be working perfectly. Tomorrow come along, and it's out again, but it's out in the way that, you know, I start calibrating it again, and I realised that the settings I'm putting in today are the ones it had 2 days ago. So why did it change yesterday? And it took me a long time to figure this one out, but I think I have. And the process of trying to work out what on earth was going on with this strange inconsistent PWM took me straight back to these. This is the old way I was controlling the servo. It was a PCF 9685 board, and it has 16 PWM channels on it, and it has 16 PWM pins on it. And I assume that this pin here is pin 1, is channel 1, pin 2 is channel 2, and so on to pin 16 being PWM channel 16. And it does seem as though on these boards every PWM channel is not created equally. I've done a bit of reading up on these things, and the ESP32 servo library is really very comprehensive, and it caters for people who might want different PWM types of devices hanging off different pins. So the way the ESP32 works is PWM channels can be paired up together, and in each of those pairs they can be assigned a different frequency. So you can have an LED hanging off it, you can have a servo hanging it, whatever, but that's kind of surplus to my requirements. But what I found, and the conclusion I've come to really just through testing, is that because the library pretty much randomly assigns a PWM channel to a servo and a pin when it starts up, if I calibrate a servo against one PWM channel that was randomly assigned to it today, there's no guarantee that if it gets a different PWM channel tomorrow, the same values are going to move the arm to the same place, which is pretty useless for turnouts. So I've ended up modifying the ESP32 servo library so that I can, at startup, I can define which PWM channel I want each servo to use, and therefore they will use the same PWM channel every time the ESP32 starts up, and the calibration values that they use today will be consistent when they start up again tomorrow. Now, an added frustration, of course, when I was doing all of this calibration of the servos and having to recalibrate them the next day, was I was also having to realign these little micro switches, because if the arm is in a different position when it's thrown or closed, then the micro switch had to be moved with it. And I got a bit sick of that. So in the end, while it was all in flux, and it is sorted now with it was the PWM channel thing by the look of it. But while I was still struggling to work that out, I decided to just stop realigning the micro switches until I'd worked it out. And that got me into a thought process of, do I actually need them? Because I didn't start off this layout with those micro switches. Although they were on all the mounts, they weren't connected. And I got on fine because at that stage, all I was interested in was throwing the motors. And if you throw the motor from JMRI, the motor moves. The reason why I added those micro switches, or connected them up at least, was when I was having problems with CMRI and the CMRI bus, and the communication to throw a servo wasn't always getting through to the Arduino. So I thought it would be a good idea to add the micro switches so that JMRI knows that the message didn't get through and it can try again if it didn't. And anyway, that didn't really work. But now I don't have any communication issues anymore. I'm on MQTT and Ethernet and Wi-Fi and all those things, and I know that the messages are getting through. Another advantage of having these micro switches was startup, because if all the micro switches are, if the arms are pressing micro switches because they're in one position or they're not because they're in another, then it was handy at startup because JMRI could be informed on what the current state of all the turnouts was, and it could carry on from there. But even that's not necessary now, because with MQTT there's persistence, and the MQTT server can save the state of the most recent messages before it shuts down, and therefore when it starts up again it will have the state of all the sensors of all the turnouts anyway, because it will have remembered the last messages that JMRI sent out when they were moved. So I soon came to the conclusion that actually there's no benefit in having these micro switches anymore. I mean, okay, they will, if a servo breaks and the arm should have moved and it didn't, and then the sensor is going to pick up that because it's not going to be pressed. But the net result, whether I've got that micro switch in place or not, is the same, because ultimately I'm going to have to turn everything off and fix the servo anyway. And I'll soon find that out whether I've got a micro switch or not. There'll be a derailment or whatever, and that would probably happen anyway by the time I'd worked out that the micro switch hadn't gone and everything else. So I've kind of come to the conclusion that for this layout now, unfortunately, micro switches just seem to be a waste of effort, and the cost of aligning them and maintaining them and wiring them and all of the pins that they take up far outweighs any benefit that they add to the layout and the operation of it. So having got the servos working, once I'd moved them off this board and onto the ESP32, I then had to think about the relays, because I'd had the relays running off the PCA9685 board, and it wasn't a good way to do it, and it was kind of done from ignorance when I started up, and maybe a little bit of laziness as well. And I'd been meaning to change the way I did it, so this was a good opportunity. Once I'd got the servos running off the ESP board, it wasn't just a case, I couldn't really just add the relays to the ESP board, because it was already running out of pins. It had at that point, it had and in fact it still does, because I haven't unplugged them yet, the micro switches plugged into it and the servos. So it was already pretty full. And they take, it's another pin per servo, and it takes up quite a few pins once you start thinking about it. So what I ended up doing was using this behind the wires, this Galileo. And I've mentioned it earlier, the Galileo, it's an old board. It's pretty much, well, very much out of support now. It was made by Intel in about 2016. It runs a very bare bones Linux. A friend recommended buying them. And they are really quite useful. And obviously they have the built-in Ethernet, which really helps with MQTT. They're supported by the Arduino IDE, just like the ESP board is. And they've got a pin out the same as an Arduino Uno. So powerful, Ethernet connected, supported by Arduino IDE, and limited number of pins. So I thought they're perfect for shift registers. So I thought, well, seeing as a shift register has 8 outputs on it, and a relay board has 8 relays on it, that seemed to work quite well. So what I've now done is I've got, again, because I mentioned this in a previous video, because MQTT, you can have more than one device subscribed to a message. What I've ended up with here for relays, if I just come out and let the wires win again, is the ESP there is for the turnouts in this corner, say for whichever one, this one. When JMRI sends the message to the MQTT broker that this turnout needs to change, because I've clicked it, or automation says it needs changing, whatever the reason is, the message goes from JMRI to the MQTT broker, and then once the MQTT broker gets it, it relays the message to any client that is subscribed to that particular topic, that topic being track/turnout/3007, whatever this one is. So then what you have this ESP there is subscribed to that topic because it knows it has control of this servo. So when JMRI sends a message to MQTT saying track turnout 3007 thrown, whatever it is, this is subscribed to that, so it picks up that message, it knows it's thrown, and it sends a message to the servo through PWM to move the servo. But also, the Galileo is now subscribed to the same message track slash, or same topic track slash turnout slash 3007. And so they both receive the message that the turnout has gone, or it needs to go to Throne. The ESP32 handles the PWM side of it for the motor, and then the Galileo knows to just handle the relay. So it updates its shift out registers to send a message to the relay over there to throw its polarity for the electrofrog. So after a bit of fuss and messing about and writing a lot more code, I now had the PCA9685 board completely off this Arduino, relays and servos handled completely independently and separately, and the problem persisted on this Arduino. So the next focus had to be on shift registers, because neither the shift in registers nor the shift out registers on this Arduino were working. That then was when my attention shifted to power supplies. Now, I'd been a bit careless about power supplies down here. I had some of those ones with a little red dial on them and you can switch the voltage on them, and I had it set to 5 volts and it was powering a heck of a lot of 5 volt stuff in this corner. It started off being plugged into that kind of sharer, and then I've also got these kind of boards that I've built because I really struggle actually to almost everything I connect that needs a 5 volt supply tends to have a DuPont type pin on the end of it, and it's very difficult to actually find something. I haven't found it on eBay or Amazon that's kind of a multi-port adapter for DuPont. So I've made a few of them myself, so these sort of chain along with shift registers and everything like that, and the idea is they just have power in and share. Each of these rows along here is a shared row, and so the top row is the row along here is 5 volts and the row along the bottom is ground, and I can just plug anything I want in and then they chain along, and to be honest they work quite well. By this point I was pretty lost for ideas, and I was kind of despairing how on earth I was ever going to get this thing back together again. And I just tried to think of all the unknowns, and one unknown for me was the quality of that Amazon sourced power supply, and I decided it might be a good idea to try and replace the power supply with a power supply that I could trust. But I didn't find it all that easy to source a power supply I can trust. I trust Amazon to send me very cheap stuff for very cheap cost, and I don't really trust them anymore, and I didn't trust them enough to think, okay, if I pay a lot of money for a power supply I'll get a better quality one. And then I had the brilliant idea of the one organisation I do trust being Merg, and Merg in their kit locker sell power supplies, and I thought, if first of all they're not out to make a profit from me, so I'm not going to be overcharged for anything, and second, they have a lot of skillful, experienced members who source this stuff, so they won't just source rubbish, they'll look into it, and they will the stuff they buy for resale will be of a certain standard. So I trusted them. I think this is it was only maybe £11 for a 5 volt power supply, and it made an instant difference. There was suddenly consistency across right down the chain, a lot less interference, a lot less unpredictability, and that was really the point when things started to improve. Another really weird one actually was this connector down here. I discovered the one that I was using, I think this was around the same time, didn't, for whatever reason, was just cheap and rubbish, and it didn't have a consistent connection to the plug. So, and I can't remember how I discovered this now, but it was constantly connecting and disconnecting, connecting and disconnecting. So the power to all this stuff up here, and I started thinking, no wonder all this stuff's failing, was just going on and off and on and off all the time. So I switched that, and again that made a huge difference. And it turned out that all of the shift registers were nuked, but I replaced them all, and then suddenly they came back to life too. So now that was all of the shift registers shifted off this Arduino, and still the problem persisted. It was overheating and sometimes slowing down terribly as well, and rebooting itself when it was connected to 12 volts. It's probably worth, I've probably mentioned this before, it wasn't doing it if it was, because I tried to debug what the issue could be, but as soon as I plugged where's my finger, a laptop into that 5-volt supply, it behaved itself perfectly. Unplugged the 12-volt supply and the thing didn't overheat, but everything still worked. So I haven't, sorry for dragging anyone who's got this far along for a bit of an anticlimax to a story, but I haven't got to the problem of why it was doing it. And I haven't got, well, I took everything off it. I disconnected everything apart from if I disconnected everything, it didn't overheat. As soon as I plugged the network board in, the Ethernet board in, it did overheat on 12 volts, but not on 5 volts. So the natural conclusion is and I obviously tried different Ethernet boards. And so the natural conclusion to come to, well, it's the, whatever it is, something about the Ethernet board that's doing it. But and it's okay, I can accept that, but what I can't accept is why it just affected this one, because I've got exactly the same setup with a whole load more stuff connected over in that corner and down there as well, and they've never, since the first moment they went to MQTT, they've never given me the slightest bit of an issue, hint that they've got an issue. But this one has just consistently refused to work. So in the end, I even tried different network cable. In the end, I just accepted it. I've just unplugged the 12-volt supply and taken it away, and I'm just using the 5-volt supply now. And what I did was I've got a USB-A cable, and at the minute it's plugged in, because it's not very far, it's plugged into the PC over there that runs JMRI, just because I've been doing a bit of debugging on it. But I've tested it in these little 5-volt USB supplies down here, and it's absolutely fine. So I'm just going to power it from a 5-volt supply from now on, and on that supply it's absolutely fine. So once I got power sorted and kind of, I don't know, worked around the 12-volt issue on the Arduino rather than actually fixed it, everything settled down and everything started working. But there was a small twist in the tail, actually. Once I got everything working, I started adding some debounce code to my sensor class, just because I'd been getting some flickering, not actually from these current detectors. It was the ones up there, actually, those ones that are a little bit cheaper and a little bit flakier. So I did some debounce code into the sketch on this Arduino, the one that's working now, to try and alleviate that. And I added it and it worked, and I thought, great. I was also having a very similar problem with current detectors down the other end that are also attached to the much busier Arduino down there. And so I updated the class and the sketch on that one, and updated that to the Arduino that had been working perfectly well previously all the time since the MQTT switch, and it stopped working, and it started behaving really strangely. It couldn't output to the console anymore. It was just outputting empty lines instead of code. It was inconsistent. Sometimes it connected to the Ethernet, sometimes it didn't, and it started displaying a lot of the issues that this one had had. And what I realized was, what I think it actually was it had run out of memory, because just those few extra properties that it took in a sensor class, that you know, there may be 20 sensors attached to the one down there, but adding 20 properties meant that for those 20 sensors, those properties were, 3 or 4 of them were created with every instantiation. So, you know, it was quite a few new variables into memory. And I think these do only have about 8 meg of dynamic memory available for variables. And I noticed when I uploaded, it was getting to kind of 65-70%. It was telling me that global variables took 65 or 75, something like that, percentage of available dynamic memory. And I think the one down there was just running out of memory, because there was nothing wrong with the code. The code worked perfectly well on this one, which was doing a lot less, because by this time I'd taken all of the turnout classes and code away from it. So it had quite a lot of capacity. But the one down there that was doing everything suddenly stopped behaving itself, and I think it was memory, because if I reverted the code back, up it went, and it was absolutely fine. So there are lots of lessons to learn from this little journey, but I think one is you can overload an Arduino long before it's full of cables. My concern with these things was always like, how will I fit all the cables onto it? But actually you can overload it long before you've attached everything, through power, through but also through memory usage. And well, that's it really. That's everything working again. I guess really the lessons I learned were that different devices have different strengths and weaknesses. The Arduino, I felt in the end I was overloading them. I was putting too many classes on and creating too many objects in those classes, and they were running out of memory. I think that's the crux of it, because it started happening on another one as well. So reducing its load. Where the Arduino is really useful is with 5-volt directly connected devices, like all of the current detectors. So whereas I have kind of started using, and I've kept the ESP and I've kept the Galileo, these things are still really useful for handling inputs from 5-volt devices, and I don't think I'm going to stop doing that anytime soon. And then moving down to the Galileo, well, Galileo, like the Uno, has a very relatively restricted number of pins, and also I'm not sure I would trust an Arduino shield on top of it. I don't think, I've never tried one, but I don't think it's kind of full Arduino really. So it takes a bit of butchering as well. When you start off, the Ethernet code doesn't really work very well, needs a bit of a tweak, but you get there and it works. And so limited number of pins, good processing power, and another strength is the direct Ethernet connection, not needing to add another board or anything like that. So I think from now on, everything that needs shift registers, whether they be in or out, is going to go through an Arduino. And last of all, the ESP, they're cheap. I mean, really much cheaper than the Arduinos. I think that the one I'm pointing at there came 3 for £21, something like that. Wi-Fi built in, so it's really easy to just stick them on the Wi-Fi and get them going. 16 PWM channels, which is incredibly useful. For me certainly, it was only useful once I could stop the dynamic allocation of PWM channels and start statically assigning them, because they seem a little bit inconsistent. They also have some pretty high quality analog read pins, which I now have a use for, which I don't have time for in this video, but I'll mention another one. Although they're actually quite limited. I think they advertise as having maybe something like 18 analog input pins, but they're on 2 channels, and 10 of those you're not allowed to use if you're using Wi-Fi, and surely anyone who's using these boards is using Wi-Fi. So that's 10 analog channels gone already, and of the 8 that are remaining, only 6 seem to have actual pins. So I've ended up, although it advertises a lot of analog pins, as far as I can tell, they only actually have, if you're using Wi-Fi, 6 usable ones. But they have the PWM, and they've got pretty high memory, decent amount of memory and processor. So, and they're so easy to add as well. They're minimal on cabling. So the lesson I've really learned from this process, and I've certainly carried it into other areas as well now, not just this corner, is that different devices have different strengths, and depending on what's needed in a particular area of the layout, a different. It's not a given as to which device you would necessarily use.